Hi everyone. Today on my bench I have a full ADX MSI motherboard, model MPG B550 Gaming Edge Wi-Fi, version 1.0. This is AM4 processor board with DDR4 memory. It has pretty decent features: audio, Wi-Fi, version 6. There's a USB-C Type-C. There's a DisplayPort, HDMI, even PS2 connector, if someone wants to have a fastest mouse movement in games. So we're going to try to fix it. It came here with no pause screen. So let's try to power it on. But before that, as usual, we should measure the resistances on main power lines. Okay, we will measure power lines on the main ATX24 power connector. So usually if you locate the connector was in this position, so the ground will be the most right and the bottom pin. And so the first upper pin is going to be 3.3 volts. And so you see that we have 944 ohms here, which is normal. The pin number 4 on the upper row is going to be 5 volts. And we have around 2-3 kilo ohms here, which is also normal. The pin number 2 from the right side of the top, right here, it is 12 volts, and we have kilo ohms here as well. The bottom second pin from here is minus 12 volts. We have mega ohms, and also I'm checking a 5 ESB power line, which is very important for, especially for power up sequence. And we have 3 kilo ohms here. This is pin number 4 from the right side at the top. So also I would like to measure some power lines which are easily accessible by coils. So this coil is a memory coil. We have 1.3 kilo ohms. This is usually 2.5 volts for the DDR memory power. So here we have, I guess, 5 volts, or also 1.2 volts for the memory. I don't see. Okay, here we go. And this is 4, 3, 2. Okay, 600 ohms. This coil here, we have kilo ohms. And I guess that I will need to remove the heatsink for the PCH, because there is a coil which is used in the power supply for the PCH. However, we can try to power it on without removing the heatsink from the PCH, and to see what current draw we will have. Okay, I do not expect that power on without the CPU. At least we can check that we have almost 0 amps. Okay, so for that purpose, we're going to use Ryzen 3 3200G. Let's put it in the socket. And yes, we would like to use one of the memory sticks for the DDR4. It's A2 slot, so this is the upper second slot for the memory we should use if we will use one stick. My power button. It should be plugged in the JFP1 header here. Okay, so let's try to power it on. It's 280 milliamps. I guess it's normal. It could be normal. Let's press the power button. And so we have no reaction to the power button. Okay. So since we don't have any reaction to the power button, so then we need to make an actual inspection just to find maybe there is some knocked off components, which is 95% of all cases. Who knows? Let's go to the microscope and check this board. What we would like to see, the first is SIO area. There could be any knocked off components, which possibly can prevent from the board from powering on. And I guess everything here looks normal. This is the audio codec area right near the SIO chip. Usually when the audio codec is damaged, this minus 12 volts is shorted or is having a low resistance. Okay, what do we have here? I see a small damage on the PCI Express connector. It's X1 connector here. Okay, let's go. Then here we have a LED switch, which is in the off and on position. Okay, so this is the power button area. And I don't see anything damaged here. Usually there could be a MOSFET or some logic element which is blown or has a damage on the package. But here it looks normal. Okay, where's the BIOS? And the BIOS is right here. It looks like the BIOS... I know, it's quite hard to say right now if the BIOS was desoldered or soldered from here, but it looks normal. I don't see any damage to the chip package. I don't see any unequal solder mask on the pins. So I guess that the BIOS chip was not desoldered from the board. Here we have right near here a JTPM header, which we can use to refresh the BIOS if we need. But sometimes it's easier to desolder the BIOS chip and just to refresh it on the programmer aside the motherboard. Okay, let's go to the CPU area. There's usually some resistors which is used in the signals for powering on right near the CPU on these boards. And I don't see anything critical here. Sometimes there's damaged parts or damage to the board in the place where the graphic card is mounted. So we need to carefully look under the clips of all PCI Express headers. But it looks normal over here. And okay, let's go to the other side of the board. CPU area, there is a lot of capacitors usually, and they look normal here. Another area is right under the PCH. There's a lot of logic components. Okay, I already see a problem. And that's it. That's a knocked off component right here. But it looks like those are the capacitors. You see that the power plane here and the plane here. So they just have different capacitance and used for filtering the signal. So I don't think this is a culprit. There's another area here. Looks normal. Here, that's the damage of the board from the mounting to the computer case. But this damage is not a culprit. I mean, those traces do not cut. But what I see here is very important. I see knocked off components, and those are not the capacitors. So there's two components over here. I bet that's resistors, but I need to check with the board view, which are absent. And so let me check the board view real quick. We have missing two components. The first component right here is a capacitor, and this component is a resistor, a knocked off resistor. So basically, because of that resistor, we don't have VDDP enable signal following to the CPU. Okay, so this resistor should be 39.2 kilo ohms, and these resistors play a role in creation of CPU VDDP enable signal. So let's solder it on and try to power the board on after that. We're going to use 39 kilo ohms instead of 39.2 kilo ohms because I don't have it in stock. It doesn't affect the signal. I am going to use this kind of a probe connected to the multimeter. It is way handy to measure small SMD components. And here we have 39.15. Okay, so this is almost what we need, 39.1, right? 39.2, but we have 39.14. This is perfect. Okay. And the capacitor we have is, I guess, 100 nanofarads for that. So let's solder it on. So I do see a little damage of this MOSFET, but I don't think that this damage is enough to make it malfunction. Like, this is just a slight scratch on the package. It doesn't look like it's burnt or something else. So if we will have a reaction on the power button press, so then that's a success. Okay, so you should have seen here. You should see the voltage and the current draw. Okay, everything is connected. Power on. The same 283 milliamps. Pressing power button. And nothing happens. Wow. So honestly, the problem is something, but not here. Okay, let's remove the PCH heatsink and try to measure voltages. Oh, wow. Wow. It is unbelievably hard. Okay. That's what usually happens when the thermal pad is already not a thermal pad, but a glue or a rock. Oh. Okay. So, let's measure resistance on this coil. This is a PCH power coil. So we have 14.6 ohms. Wow. Is it normal or not? I don't know. Let's try to power it on and to see if we have any voltage on it. So, let's try the CPU as well. Let's try to power the CPU also. Okay, power on. Let's see if we should have power here. even... Okay, no, I don't need this. I need to go switch to the voltage meter. What voltage? We have 1.2. Okay, so it goes from this side. It's 105. So this is normal. We don't have any short here. All right. What else do we have? 2. Okay, we don't have 2.5 volts here. 1.8 volts here. Nothing here. Okay, nothing here. And nothing here. Okay. Should have 3.3 or whatever. Okay, what's the 0.73 volts over here? There should be 3 volts or 5 volts at 3 volts. Yeah. This is interesting. And the power button has voltage. Okay, so the power button voltage is here, right? We do have it. Okay. Okay, so we have a voltage for the power button, 3.3 volts. We should probably have 5 or 3 here. It's 4.8 volts. Okay. Let's assume this is normal. But I'm not sure. There's a small coil over here. Okay, let's see the board view. And I guess we removed the heatsinks before. Okay, I'll remind myself that doing a good visual inspection before touching anything definitely saves a lot of time. What I didn't notice at first is that someone has actually written on the board. You can see here, there is some kind of ancient hieroglyphics. Not sure what that message they were leaving me. It doesn't really look like an arrow, but let's take a closer look under the microscope and figure out what's going on. So, as you see, right here, there is someone already tried to fix that, because this is definitely was soldered using the soldering iron, not even a hot air. There is a missing component over here. I'm not sure about this. Let me check over the board view. And no, there should not be any component over here. But here is the resistor, which basically pull up the proc hot signal. And if we go a little bit to the side, so you can see that here you have a knocked off components as well. Those are the resistor 2.2 kilo ohms should be mounted over here. Here should be a resistor 2.2 kilo ohms as well. And those capacitors, they're not knocked off, they shouldn't be here. So, but there's definitely the area was damaged and those two components were knocked off. So let's fix this and see if we have any changes. Okay, let's see if we have fixed the board, or we'll have to search for another written message on the motherboard. Also, let's clean the PCH chip by removing this ugly degraded thermal pad. I will use fresh thermal pad for that, because, well, usually the thermal pads can work for 2, maybe 3 years, well, sometimes 5 years, but if we're talking about the good thermal pads, quality thermal pads, not sure that the manufacturer of those motherboards use very quality thermal pads. Let's try to power it on. Finally, will we have a reaction on a power button or not? Okay. Check. Our power button, our CPU. Let's put the memory even. Okay. Power on, 283 milliamps, and pressing the power button. And here we go. Okay, CPU LED eliminated, and we have, oh wow, CPU getting hot. Okay, and the power consumption, I forgot to show you. Here we go. But still have CPU, and it's unclear if we do power on or no. Is it booting? Like 3 amps, then 2 amps, 2.7, 2.8. Okay, so it shows me boot. Let's plug in the HDMI cable for my capture card and see if we have any success on this. Okay. So I will show the pause screen here. Okay. Powering on. Boot, DRAM. Now then get CPU. CPU, DRAM. Come on. Okay, VGA. Will we have a boot screen right here? And we do. Yes. Finally. What BIOS version do we have here? Let me check. Let's do this. So we have a BIOS version of 2021. So it's 4 years outdated. We definitely will need to update it. But we're not gonna do it with the desoldering. I guess that we will use our BIOS update feature of this motherboard. Fantastic. That's what I wanted to see. Okay, I'm going to test this board and mark it as repaired. I hope this repair journey was interesting for you. If you enjoyed, please don't forget to like and subscribe. It really helps the channel grow. Your support means a lot. See you in the next repair. See you.